Our next unit is titled The Electronic Structure of Atoms, and we're going to now look into how electrons and atoms give some very unique properties of these atoms, and we're going to go into a branch of chemistry called quantum mechanics. So the chemical behavior of atoms is almost entirely determined by the number and arrangement of the electrons. And understanding of the energy of the electrons and how they interact allows a chemist to explain many chemical and physical properties. So what we have to do is kind of get a background for how these electrons are going to behave inside of an atom. So before we dig into that, we need to talk about something called electromagnetic radiation. And electromagnetic radiation is going to travel through space as waves. So when we are looking at this, we need to start talking about wave-like behavior. So let's just say we have two waves that we're going to represent. The first one being wave A. That's going to look something like this. And wave B, which is going to look something like this. And we'll use these two waves to kind of define some of the nomenclature that we're looking at. So one of them is the wavelength, which we can kind of define as the distance between two peaks of the wave, or the same part of the wave. So here's the wavelength of A, and here is the wavelength for B. So the wavelength is going to be the distance between two peaks on the same wave. The Greek letter nu is used to abbreviate the frequency. And the frequency is the number of peaks that pass a given point per second. So if we look at these, the wavelength for wave A is going to be greater than the wavelength for wave B, whereas the frequency of wave B is going to be greater than the frequency for wave A. So when we analyze waves, or when chemists started to analyze these waves, when they travel in a vacuum, all waves are going to travel at the same speed, which is the speed of light. So the speed of light is represented as c, and that's going to be equal to 3.00 times 10 to the 8th meters per second. And this allows us to come up with a couple relationships. By looking at these diagrams right here of A and B, we can say that the relationship between the frequency, which is nu, is going to be proportional to 1 over the wavelength. And we can come up with a relationship using the speed of light to say that the frequency is going to equal c divided by the wavelength. And if we carry out this formula and look at the units, typically the speed of light is represented in meters per second. The wavelength is a distance which can be represented in meters. Meters will cancel out here, and our units are seconds to the -1, which we will refer to as a hertz, and that is abbreviated by Hz with a capital H. So this kind of gives us a little glimpse of what electromagnetic radiation is, and we can use this type of information to look at the electromagnetic spectrum, which will be the topic of our next video.